Hi everyone. Now let us try to solve some problems on jet parameter model. So problem number 1 is solving of jet parameter. So the question given is find the jet parameters for the following network. Find the jet parameters for the below network. So how to find out? Let us try to see here. So here you are going to have an the question is given is an impedance of Z1 and an impedance of Z3 and impedance of Z2, and this is excited with a voltage an input voltage of V1, and this network is drawing a current of I1, and the given input voltage is V2 and is drawing a current of I2. We need to find the jet parameters for this network. So how to find the jet parameters? You see here. So this is V1 is applied, current is entering. This is positive terminal, negative terminal. The current I1 flows here, and from this branch the current is entering. This is positive, this is negative. So the current in this branch I am going to label it as Ix. So now we are going to. So this is the network given. For this network, he is asking us to find out Z parameters. What are the Z parameters? Z11, Z12. We need to find out. We need to find out Z21 as well as Z22. How to find out? So I am taking this current is entering is positive, negative. If the current entering the impedance is positive, negative, and current entering this impedance is positive, negative. But I want to find out this unknown current. So you apply the Kirchhoff's current law at this node. Okay, so when you apply this Kirchhoff's current law at this node, so here you are going to get entering currents. What are the entering currents? I1 is one entering current. What is the next entering current? I1 plus I2 is entering. The leaving current is Ix. Okay, so this is the leaving current Ix. So how we are going to write down this current? Ix is, so now the current Ix is equal to, the current in this branch is I1 plus I2. So now try to apply the KVL to the input loop or input port. So the voltage at this point is plus V1. So this is plus V1, and current is leaving. What is the leaving polarity? Minus. What is the drop created here? Minus I1. What is the impedance given? Z1, and the same current flows here. And what is the leaving current? This is nothing but minus. And what is the name of this current? Which is nothing but I1 plus I2 into, what is the impedance? Z3 is equal to 0. So this equation is obtained by applying Kirchhoff's voltage law at the input port. So now we are going to apply Kirchhoff's voltage law at output port. That output port, when you see here, current is entering, current is leaving. Okay. So what is the magnitude of this voltage? Voltage is what is the polarity of the voltage, which is nothing but plus V2. Current is entering at positive and leaving at negative. What is the leaving polarity we have? Minus. Okay. So minus, what is the drop? Minus I2 Z2, minus I2 Z2. I into R is once again the voltage. And what is the drop in this branch? Entering is positive, leaving is negative. So minus, how to write down the current? This is I1 plus I2 multiplied with the impedance, which is nothing but Z3 is equal to 0. Now let's try to segregate in the standard format. So when you write down this, V1 is equal to I1 Z1 plus I1 plus I2 into Z3. So this we can write down as V1 is equal to, let us try to take I1 as common. When you take I1 as common, this is Z1 plus Z3 Next left component is plus I2 into Z3. So this is the one equation. So when you write down shifting these negative terms to the right hand side, so V2 is equal to I2 Z2 plus I1 Z3 plus I2 Z3. So I'm segregating this in the standard format. V2 is equal to I2 Z2, and what is the, take I2 as common from this equation, Z2 plus Z3 plus I1 into Z3. Okay. So when you shift it to the earlier, so you can write down I2 is equal to I1 into Z3 plus I2 into Z2 plus Z3. So already we know the standard equation. Compare this with the standard equation. So V1 is equal to I1 into Z11 plus I2 into Z12. Z11 plus Z12. So V2 is equal to, for the standard equation, V2 is equal to Z21 I1 plus Z22 into I2. So when you compare, the equation of Z11 is Z1 plus Z3. The value of Z3 is this one, and Z21 is Z3, and this value is Z2 plus Z4. So resultantly, we are going to get the input driving point impedance is Z1 plus Z3, Z12 is equal to Z3 ohm, Z21 is equal to, what is Z21? Z3, and Z22 is equal to Z2 plus Z3. So this is the resultant what actually we require. Sir, how to understand this kind of equation is very simple. So when you see here, a T network is given for us and asking us to find out Z parameters, very simple. So Z11 is the sum of series branch plus shunt branch. Okay, so this is a sum of series branch and shunt branch, which is Z11 plus Z2. And when you come to the reverse transfer impedance, this is nothing but only shunt, or the shunt value only Z3. And transfer impedance, I mean reverse transfer impedance, we are going to write down, this is nothing but forward transfer impedance. This is reverse transfer impedance. This is input driving point impedance. This is output driving point impedance. So this year we are going to have, when you are writing this output driving point, we have to add the sum of Z22 plus Z3. So whatever you get the problem, this is the standard format you have to remember. So if you practice, then you can understand this kind of impedance very simple. So these equations are also very important. So V1 is equal to I1 Z11 plus Z21 I2 Z21 I1 plus Z22 I2. So now one more problem. Let's try to solve. This is how to find the first problem. So problem number 2. Find the Z parameters for the network shown below. So the network given is This is the problem given to us with the input voltage of V1 and drawing a current of I1, the input voltage of V2 and drawing a current of I2, and this value is 5 kilo ohm, this is 3 kilo ohm, this is 12 kilo ohm. If you solve it by above procedure also you'll get same. Let's try to solve it. So if you solve by above procedure, let's try to verify by two methods and shortcut. So what is the value of Z11 we are supposed to get? Z11 is nothing but Z1 plus Z3. I mean these two values. Okay. So this is 5 plus 12 kilo ohm. What is Z12, which is nothing but the shunt branch. Shunt is 12 kilo ohms. Next one, second row first column element is also the 12 kilo ohm, and what is the output driving point impedance is the sum of these two elements. It's nothing but 3 plus 12. So 3 plus 12 kilo ohms. Whether we are getting this or not, we can solve it by applying an KVL also. So when you see here, when you apply the KVL, entering current is positive, negative. Here the entering current is positive, negative, and the current in this branch is I1. The current in this branch is I2. I want the current in this branch. So try to apply Kirchhoff's current law at that node. So what are the entering currents to this node at this point? So I1 plus I2 is equal to I x is unknown current. So now when you redraw it, so you're going to get the equation like this. So when you redraw it, so you're going to get the equation. This is 1, 2, 3. So now this is V1, this is V2, and this is current I2, and this is current I1. The current in this branch is I1 plus I2. This is current is entering, leaving is negative. Current entering is positive, leaving is negative. Current entering is positive, current leaving is negative. So try to apply the Kirchhoff's voltage law in input side or input port. So when you write down this, so this is 5 kilo ohm, this is 3 kilo ohm, this is 12 kilo ohm. So what is the advantage of these videos is you should first listen the concept and you should write down the problem, you should solve it, and you should match the answers are correct, then automatically you can find better. So when you write down this, so when you see here the total voltage is, we can write down it as plus V1. The current is leaving, what is the leaving polarity of the voltage, minus I1 into 5 kilo ohm, and the current leaving is negative terminal, minus of what is the total current, I1 plus I2 into multiplied with 12 kilo ohm. Okay, so that equal to 0. Next equation, you try to apply it output side. So this is nothing but plus V2. So this is positive, this is negative, this is plus V2, and current leaving terminal is minus I2 3 kilo ohm is the drop, and what is the current flowing in this branch? It's nothing but minus what is the current, I1 plus I2 into 12 kilo ohm. So now segregate in the standard format. When you segregate into standard format, V1 is equal to I1 into 5 kilo ohm plus I1 into 12 kilo ohm plus I2 into 12 kilo ohm. So V1 is equal to, take I1 as common, I1 is equal to 5 kilo ohm plus 12 kilo ohm plus I2 into 12 kilo ohm. So this is the standard equation. Compare with the standard format. V1 is equal to I1 into Z11 plus Z12 into I2. So Z11 is 5 plus 12, Z12 is 12 kilo ohm. So when you compare, you can see here Z11 is 5 plus 12 kilo ohm, Z12 is 12 kilo ohm. When you write down this also in the standard format, so V2 is equal to I2 into 3 kilo ohm plus I1 into 12 kilo ohm plus I2 into 12 kilo ohm. V2 is equal to, let's write down the I1 term, I1 into 12 kilo ohm, take I2 as common. So when I2 is common, this is 3 kilo ohm plus 12 kilo ohm. So when you compare it with the standard format, so V2 is equal to I1 12 kilo ohm plus, so standard format is V2 is equal to Z21 I1 plus Z22 I2. This you have to remember in the brain. So Z21 is 2 kilo ohm, Z22 is 3 plus 2. When you compare it with the standard format, then you can understand here clearly. So now Z21, this is Z21, so Z21 is 12 kilo ohm, Z22 is 3 plus 12, 3 plus 12. So without solving also we can write down. So Z11 is 5 kilo ohm, Z11 is 5 plus 12, the shunt and series branch. Z22 is 3 plus 12. So Z12 is only shunt branch. Shunt branch is 12 kilo ohm. Z12 is also 12 kilo ohm. This is how to solve a problem when you get a problem on these impedances. So this is very important while you solve multiple problems. Hope you're able to understand. Next we'll continue with the next two problems of two types of method. Thank you for watching. So if you feel the content is useful, please like, share with your friends, and if you have any doubts, let me know in comment section. And this is a free channel. Kindly encourage this channel, which will be like a motivation for us to do more videos. Yours obediently, Ram. Meet you in the next class. Thank you for watching.